హలో ఎవ్రీవన్. పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 14 మనకు పర్ముటేషన్ కాంబినేషన్ టాపిక్ నుంచి ఒక 4 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తున్నాడు. లెట్ us see ఫస్ట్ క్వశ్చన్. ప్రూవ్ దట్ 4n c2n divided by 2n cn equal to 1, 3, 5 and so on 4n minus 1 divided by 1, 3, 5 and so on 2n minus 1 whole square. This is the question. Select LHS part and apply NCR formula. LHS is given by 4n c2n divided by 2n cn. 4n c2n value 4n factorial divided by 2n factorial into 2n factorial. Next, and it is divided by 2n cn value 2n factorial divided by n factorial into n factorial. It is using NCR formula. You can write n factorial by n minus r factorial into r factorial. Here it is applied NCR written as n factorial by n minus r factorial into r factorial. Using this, you got numerator and denominator part. Next, now it can be rewritten as 4n factorial divided by 2n factorial whole square multiplied by here n factorial whole square divided by 2n factorial. Yes. Now in the next step I can write 4n factorial written as 1 into 2 into 3 into 4 into 5 into 6 and so on into 4n. Next, n factorial written as 1 into 2 into 3 into 4 into and so on n whole square whole divided by, and here in the denominator part 2n factorial whole cube, that is, so that 1, 2, 3, 4, 5, 6 and so on 2n whole to the power of 3. Next, here from the first bracket only odd terms I am going to write 1, 3, 5, 7 and so on 4n minus 1. Remaining even numbers 2, 4, 6, 8 and so on 4n it is. Next, this one 1, I am going to separate 1, 3, 5 and so on n minus 1. No need. 1 to n as it is 1, 2, 3 and so on n whole square it is. Okay. Next, now in the denominator part, here if you take odd numbers 1, 3, 5, 7 and so on 2n minus 1 for which whole cube you have. Next, even numbers 2, 4, 6, 8 and so on 2n whole power 3. Now I am rewriting this 1, 3, 5, 7 and so on 4n minus 1. Next, here from each term if you take 2 common, what happens? 2 into 1, 2 into 2, 2 into 3, 2 into 4 and so on 2 into 2n. How many 2's you can take out? 2n times, so that 2 power 2n remaining 1 2 3 and so on 2n you will get. Next, this is 1 2 3 and so on n whole square it is. Next, here odd numbers 1 3 5 7 and so on 2n minus 1 whole cube it is. Next, here from each term you can take 2 common. This is 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into n. So you can take 2 common n times. And again here you have power 3. So you can write 2 power 3n. Remaining internal part 1, 2, 3 and so on n whole power 3 it is. Now in the next step I can write 1 3 5 7 and so on 4n minus 1. Next, here 1 to 2n you have 2 power 2n as it is. 1 to 2n written as 1 3 and so on 2n minus 1 separately. Even numbers 2 4 6 and so on 2n separately. And here 1 2 3 and so on n whole square, and here 1 2 3 and so on n whole power 3. If you simplify last terms, then in the denominator part you will get only this 1 2 3 and so on n. Here you have 2 terms, here you have 3 terms, only 1 remains. Next, 2 to the power of 3n, and this is 1 3 5 and so on 2n minus 1 whole cube. Now in the next step I can write let us continue this. Now this is equal to 1 3 5 and so on 4n minus 1 2 power 2n. This is 1 3 and so on 2n minus 1. Here in each term you can take 2 common, 2 into 1, 2 into 2, 2 into 3 and so on 2 into n. So you can take common 2 to the power of n. Remaining 1 2 3 and so on n we get, whole divided by 1 3 5 and so on 2n minus 1 whole power 3 2 power 3n. Remaining 1 2 3 and so on n. These two terms gets cancelled and these terms also gets cancelled. And here solving these two, in the denominator part you get only perfect square. Yes, you have the same. And in the numerator what we get? Odd numbers as multiples up to 4n minus 1. Yes, this is your RHS part. Let us move to the next question. Simplify 34c5 plus summation r from 0 to 4 38 minus r c4. This is the question. Yes, 34c5 first term plus summation r from 0 to 4 38 minus r c4 it is, and this can be written as 34c5 plus, here sum of terms by writing r value 0 1 2 3 4 you will get. First if I write r value 0, that is 38c4. Next plus if you write r value 1, 38 minus 1, that is 37c4. Next what we get? 36c4 and then 35c4. After that, what we get? Finally, 34C4. This is by writing R value 0, 1, 2, 3, 4. Now, 34C5 plus 38C4 plus 37C4 plus 36C4 plus 35C4 plus 34C4. I am going to solve these two. You know that sum of successive binomial coefficients, formula NCR plus NCR plus 1 equal to n plus 1 CR plus 1. This formula you can use here. Using this, if n value same, only binomial coefficient in which R value, suppose if you have R plus 1 successive terms, greater 1 here in the suffix, next here n plus 1, 34C5, 34C4, like successive binomial coefficients. So these two written as 35C greater among these two, you have to write 5, remaining 38C4 plus 37C4 plus 36C4 plus 35C4. Now sum of these two I am going to write with the help of that formula. 35, 35, when you have index n, 35C5, 35C4, both successive binomial coefficients. Then what we get? N plus 1 C of R plus 1. N plus 1 value here 36, C, R plus 1, that is greater index 5. Remaining 38C4, 37C4 plus 36C4. Now adding these two, sum of successive binomial coefficients gives 37C greater 1, 5 plus 38C4 plus 37C4. Now sum of these two, 38C5 with the formula plus 38C4. Again using the same formula, we get 39C5 is the answer.